Welcome to this course on building truly secure web applications with PHP and Symfony. My name is Bo Carnes, and I developed this course. Data breaches are a constant threat, and standard encryption practices are no longer enough. We need to build systems where sensitive data is protected throughout its entire life cycle, at rest, in transit, and most critically, in use. This comprehensive step-by-step tutorial will guide you through building a fully functional financial transactions application from a completely empty directory. We'll explore the why behind the code and dive deep into the core concepts to give you the skills to architect secure applications on your own. We're going to construct a web application for managing personal finances. Users will be able to create accounts, log transactions, and view information. We'll make sure that critical data is cryptographically secured within the database, and we'll see how to retain the ability to perform meaningful queries on this encrypted data. We need to be able to find a user by their social security number or find transactions within an amount range, all without ever decrypting the information on the database server. This has long been a major hurdle in application security, and I'll show you how to solve it. I'm using a modern, powerful, and security-focused stack to accomplish the goal. PHP, the backbone of our application. We'll leverage PHP's modern object-oriented features and robust performance to build our back-end logic. Symfony, a leading PHP framework that provides the structure, components, and best practices necessary to build maintainable and scalable applications. Its focus on solid design patterns makes it a perfect choice for a complex project. MongoDB Atlas. Our database of choice is MongoDB, hosted on the fully managed Atlas cloud platform. Its flexible document model is ideal for the varied data of a financial application, and Atlas frees us from the complexities of database administration, letting us focus on our application's logic. Also, MongoDB provided a grant to make this course possible. Doctrine MongoDB ODM. To bridge the gap between our PHP objects and MongoDB's document structure, we'll use the Doctrine MongoDB Object Document Mapper. This powerful library allows us to work with our data as native PHP objects, making our code cleaner, more intuitive, and less error-prone. MongoDB's Queryable Encryption. This is an important component of our security model. Queryable encryption is a revolutionary industry-first feature that allows us to encrypt sensitive data fields directly from the client side, our PHP application, store this data as fully randomized encrypted fields in the database, and run expressive queries like equality and range checks on the encrypted data. This is all achieved without the server ever having access to the unencrypted data or the encryption keys. The data remains secure throughout its entire life cycle. So we're moving beyond simple encryption at rest. We're building a system where the database itself cannot decipher the sensitive information it stores and processes. This tutorial is designed for people who already know a bit about PHP and have some experience with a framework like Symfony or Laravel. However, even if you're brand new to these technologies, you should still be able to follow along. So, let's begin.
So let's start with some setup. First, we'll make sure we have PHP, Composer, and the Symfony CLI installed. And we need the MongoDB PHP extension. So let's check if it's installed by running php -ri MongoDB. And good, we need at least version 1.21. Okay, let's create a new Symfony project. We're going to call this one Financial Harmony. And we can just run the create command, and we'll just change into the directory. Now let's pull the necessary dependencies. We'll need the Doctrine MongoDB ODM bundle to work with MongoDB. And now we will need maker bundle, to help us generate some code. For the front end, we'll use a simple HTML file, so we don't need any complex front end tooling for this tutorial. Okay, I got our folder open in Visual Studio Code, and now we're going to configure the database and encryption. This is an important step, as encryption is a key part of this tutorial. So we need to configure our application to connect to MongoDB and enable Queryable encryption. So first let's set up our environment variables. So I'm going to go into the .env file, and we need to add our MongoDB connection details. So we are going to add our MongoDB URI, our database, and then our MongoDB encryption key. This is needed for the queryable encryption. So let's get this information. Well, for the MongoDB URI, we could connect to MongoDB locally, but we are going to use MongoDB Atlas to have our database in the cloud. Okay, I'm on MongoDB.com and I'm going to sign in. If this is your first time signing up for MongoDB Atlas, it will guide you through creating your first project and database. But if you already have a MongoDB account and you want to create a project, we can go to the down arrow here and new project. And I'm going to call this Financial Harmony and next. And we'll create the project and I'll create a cluster. Now I'm going to use the free plan, which is great when you're just trying things out. And I'll just keep all this as default. We can change the region to a region closest to us. Mine probably is Virginia. I'm in Michigan. And we'll create the deployment. So I'll create my username as Bo, and for my password, I'll use a super secret password freeCodeCamp. I'll be deleting this before this tutorial goes live, so this is just basically a demo user. And now I will choose a connection method. Oh, first create database user, and then choose a connection method. And this is where we are going to get our connection string right here. So I can just copy this right here, and this is how we'll connect to our database. So right in our environment variable, I can just paste in the connection string. There we go. And our database, we will call Symfony Harmony. And then we need to make our MongoDB encryption key. Let's go into our terminal. So I'll do a new terminal here, and we can generate the key with our computer with OpenSSL-base64 and 96. So let me copy this, and then we'll just put into here, and we just have to make sure it's one line instead of two lines. There we go. And we'll create our app secret up here. So back down in my terminal, I'm going to run the same command, but instead of 96, we're going to make it 32. And then I can just copy this, and this will be our app secret. Okay, now we're going to need something else. We need to set the path of the MongoDB cryptographic library, our MongoDB crypt shared lib path. So I'm on the MongoDB documentation about queryable encryption, and it shows that we need to go to the MongoDB download center. And then we got the version, we keep all that the same, and then I'm going to download crypt shared. Okay, then I'll just click download, and then we can put in all information here. Now I'm just going to unzip the directory, and then we go into lib, and we can copy this file, and then in my Financial Harmony project directory, I'll go to bin, and then we can create a lib folder, and then inside that folder, I'll just paste in the MongoCrypt v1.dylib. Okay, now I can just put the directory, it guessed it, but that was wrong, so I'll do lib/bin, and we'll just put some quotation marks around it, and we can check this in here, bin/lib, oh I got it wrong, bin/lib, not lib/bin. Okay, and just one more thing about the MongoDB encryption key. This is the local master key for encryption. For production, you would use a key management service like AWS KMS, Google Cloud KMS, or Azure Key Vault. But for local development, the way we're doing it is sufficient. Actually, we're not going to have a slash before this, and it's actually .dylib. Okay, we're going to go into another file, which is config, packages, and then the Doctrine MongoDB. And I'm going to add some settings to make sure the encryption works correctly. So we've added this auto encryption. This is going to make our encryption work. And then we have to add the path to that library we just got put into our directory. and our KMS provider. In this case, it's local, like I was saying before, and our encryption key. So that's going to be important to make this all work. Okay, we got a lot of our setup done. Now let's create the document classes. So we're going to define our models, which are called documents in MongoDB. So I'm gonna create a new folder, an src, well, the folder already exists, document, and we're going to create a new file called account.php. Now we'll create two documents, the account, which we just created, and later a transaction. And these are the files where we'll define our data models and also tell Doctrine which fields to encrypt and how they should be queryable. So I paste in some code here. This is a Doctrine ODM document, which is a special PHP class that maps directly to a MongoDB document. So let's break it down. So we have to make sure to import some things, including the encrypt query, encrypt, and then we see this ODM document collection accounts. This is a PHP attribute that tells Doctrine, hey, any object created from this account class should be saved in a MongoDB collection called accounts. Then we have the standard properties like ID, and we have customer name, account number, and balance, and such. And when we see ODM/ID, that marks the ID property as the unique identifier for each account document in the database. MongoDB will handle generating this for us. And the type string, it tells Doctrine to map a property to a field in the MongoDB document with a specific data type. So this will be stored as a string. When we get to this account number, so this is the first one that's going to be encrypted. So we see two parts here. Well, besides that it's a type of string, we have where it says encrypt. This instructs the MongoDB driver to automatically encrypt this field before sending it to the database and decrypt it when it's read. The database never sees the unencrypted data. This is important. And the second part here, query type encrypt query equality, this is what makes queryable encryption so powerful. It tells MongoDB to encrypt this field in a specific deterministic way that allows for equality checks. This means we can still run a query like find the account where the account number is X, even though the data is fully encrypted. And then we do the same thing for this social security number field. And then we have a few more fields that are not encrypted, like email, created at. But let's go back, and then let's go back to this balance one. So I'm going to zoom out a little bit, and we can see what it shows here. So here we're using encrypt query range. This enables us to perform range queries on the encrypted balance. We can ask the database for all accounts with a balance between, say, 10,000 and 50,000. So this allows us to search for things that are not just exact matches while keeping everything encrypted, because the balance will be encrypted. And we have the min, max, precision. That's going to help MongoDB optimize the encryption process for these numerical range queries, which will make them efficient and secure. And then we just have some getters. So we have some getters and setters. So these are functions to get the information, and these are functions to set the information. All this is pretty straightforward here. So now our application code can work with the data as if it were plain text, even the encrypted data, while the data at rest in our database remains completely secure and unreadable to anyone without the encryption keys. So that's the power of MongoDB's queryable encryption integrated into Symfony. And so I'll save this, and we'll create our next document file, which is just going to be called transaction.php. And just like before, I'll paste in some code here. And this is all pretty similar. It's the same format as the account. So we have the different fields like the ID, account number, amount, transaction type, description, card number, CVV, and expiry date. So and a lot of this stuff is encrypted, like the card number is encrypted, the string is encrypted, and we're not doing any special types of queries, except we do have that for the amount here, the range queries, and the rest of them are basically these equality queries here. I guess one thing interesting about this is some of the things like the card number, CVV, and expiry date, we have, it just says encrypt, but they're non-queryable. So these fields don't have a query type, which is a deliberate security choice. This setup uses randomized encryption. So the data is still fully encrypted on the client side, but because we don't need to run queries like find all transactions using this CVV, we can use a more secure, non-deterministic encryption method. This provides the strongest level of security for data that you only need to store and retrieve, but never query against directly. And everything else is pretty much the same. We have our getters, we have our setters, and that's it for our documents. Okay, now we are going to build the financial service. This is going to handle the business logic of our application. This service will be responsible for creating and retrieving accounts and transactions. So we are going to go to SRC, and I'm going to create a new folder. So I'm just going to create the folder and the file at the same time. So it's going to be called service/financial service.php. Okay, I put in the code for the financial service file. If the document classes are the skeleton of our application, the service class is the brain. It contains all the business logic for handling accounts and transactions. It basically acts as a bridge between our controller and the database. So we're using some libraries up here, and then we have our financial service class. So the first thing to notice is the constructor. So thanks to Symfony's auto wiring, the document manager is automatically injected into our service. The document manager is the main workhorse from Doctrine's ODM. It's what we use to save, fetch, and query our account and transaction documents. So now let's look at create account, and then there's also a create transaction method. So they're going to take in plain unencrypted data. So we have the customer name, account number, and so on, everything through the email. And then they're going to create a new account or transaction document. So in this case, we're creating an account document. And then we're setting all the information that we got passed into this function. And then we're calling document manager this persist and then flush. So basically these are saving it to the database. And notice there is zero encryption related code in these methods. Our service layer doesn't know or care that the account number, social security number, or balance will be encrypted. It just works with the objects. The Doctrine ODM, powered by the MongoDB driver, handles all the encryption transparently in the background based on the attributes we set in the document classes. This is a perfect example of abstraction. Our business logic is clean and completely decoupled from the security implementation. And the create transaction function is pretty similar. Now it's different lines instead of all in one line, and we're setting the new transaction, we're saving to the database, and so on, and returning it. So now we have our functions, basically the getter functions or the find methods. So we have find account by number, find account by balance range, find transaction by account number, and so on. So this is where we can really see the power of queryable encryption. So we have these equality queries like find account by number, or we also have find account by social security number down here. This code is a standard Doctrine repository call. We have find by one, and then we are looking for the account number. So we're basically we're querying directly on the account number field. So yeah, we get first we obviously we get the repository and then the find by one. Even though this field is encrypted in the database, the query works perfectly because we've marked it for equality queries. The driver encrypts our query term before sending it to the server, allowing for a secure match. And then we have queries like the range queries, find accounts by balance range, where we get passed in the minimum balance, the maximum balance, and we can do document manager, create query builder with the account, and then we are looking for the field balance greater than or equal to the minimum balance, less than or equal to the max balance, and then you can see we return the QB get query execute to array, and so it's going to return an array of accounts within that balance range. So we're using the query builder to find accounts where the balance is greater than or equal to the minimum and less than or equal to the maximum. So this code here is identical to how you would query an unencrypted field. The driver just handles the range query on the encrypted data. So you basically can still have good security without sacrificing any query capabilities. And then we have the rest of the functions, which are all pretty straightforward. Find transactions by account number, by amount range, by security number, and then we can get all accounts where we are going to find all and send back all the accounts, and get all in transactions where we're going to find all the transactions. Okay, now we're going to create the controller. We're going to create our controller to expose our financial service as a set of API endpoints. And we'll use the maker bundle for this. So in my terminal down here, PHP bin/console make controller financial controller. And we'll just use the default here. Okay, we created the controller. So let's go into our controller file that we just created. So we'll go to the src controller, and then we have financial controller. So I've updated the controller with some more code. So it's the public face of our application. It's responsible for defining the API endpoints, receiving incoming web requests, and sending back JSON responses. Basically like a traffic director, taking requests from the user's browser and passing them to the correct method in our financial service. So we got all of our what we're using up here, basically our imports, and then we have our we're using dependency injection. So our constructor right here, this is the part. Our constructor is injecting our financial service into here. This gives the controller access to all the business logic we defined, keeping our code clean and organized. And then we have the homepage route. We're going to use another cool Symfony feature, which is AutoWire, to inject the project directory path. So we have it just like this. It's basically best practice for accessing files without hard coding paths. And then we have our success response, where we're passing back some data, or our error response when we're passing back an error message. Okay, let's look at our create account method. So we have first our route. This attribute defines the URL and the allowed HTTP method for this endpoint, which is a post request. And so a post request to this URL will trigger this method, this function, this create account function. And we have request get payload. So instead of manually decoding JSON, we use this convenient method to get the request data as an easy to use object. Then we call the service. So we have financial service, create account. The controller's main job is to orchestrate. It extracts the data and immediately passes it to the create account. So here's all the data being passed in here. This controller doesn't know how an account is created. It just delegates the task. And then we're going to call the success response method. That's what was defined up here, where we basically pass in or pass over the message and the account ID. And we also handle errors here. And it's pretty much the same for when we're creating a transaction. It's just a different URL route, but again, we are creating using the create transaction function that was already defined, passing it all the data, and then returning the success response and the error response. Okay, now on to some GET request endpoints. They basically follow a similar pattern. So the GET request for balance range is going to grab the min and the max. These values are going to be from the URL's query string. So we're looking for the key min, the key max, or we have these default values. And then we're just going to call this function, find accounts by balance range, passing in the min and max. And then we are going to create this array with all this information from every transaction, or every account, I mean. And then we can return the account data and the number of accounts here. Now, this GET request, you can see we are getting the account number directly from the URL. So the curly brackets means that this could be variable, depending on what the account number is. And then just like before, find account by number, and we're basically either there's not found or the success response. We're going to pass back all the information from the account. And similar, so this is going to be the get transactions by account number, where we're still getting the account number from the URL, but this time we are finding transactions by account number. And again, it's pretty straightforward. Just like before, we are looping through all the transactions and getting an array using array map of the data from all the transactions. We're passing it back. And then we have another range request of the transactions. Pretty straightforward. Find account by amount range. And this is all just like before. We can also search by social security number and then return the amount. We can just get all the accounts, get all accounts, and again, passing the information back as an array. We're going to get the transactions, get all transactions, and we have the get account summary, where again, we're getting the account number right from the URL, and find transactions by account number, and we're calculating the average transaction amount. So that's nice that we can actually calculate things right within there. And then we have get account balance history. So these are just all the methods that we need to be able to get what we need. And then we have a debugging route where we're going to get encryption status and just see if these are encrypted correctly. And with all this, when the controller receives objects from the service, the sensitive data like account number and social security number, they're already decrypted. So this basically just happens all in the background when Doctrine retrieves the data from MongoDB. Okay, we'll save that. And next, we are going to create the encrypted collections and demo data. So to make Queryable encryption work, we need to create our MongoDB collections with the correct encryption metadata. We can't just insert data and expect it to be encrypted. So the correct way to do this is with our Doctrine MongoDB schema create command. And then we need a command to populate our database with some demo data. So let's create a command that will basically create our demo data. So I'll do php bin/console make command app demo data. And then we can go to where it's been created, demo data command. Okay, so I paste in the code here, and this is basically going to be a console command that we can run from the terminal to perform specific tasks. And like I said, it's going to just populate our database with a fresh set of sample data. So we have the as command attribute, which is basically going to register as a command with Symfony's console application, and it has the name app demo data, which is what we'll type in the terminal to run it. And we're gonna get some dependency injection with our financial service here. And the main logic is within the invoke method. And then we have this IO Symfony style IO, which is gonna make the output look nicer in the terminal. So the core of the command, so we have create accounts and create transactions. And so the core of the command is in these helper methods. So here's the accounts that we're going to create, and it's just going to run create account for each of these example data. And then we are going to basically do the same thing with the transactions, create transactions, and that's going to create these sample transactions data. And you can see for each transaction called the create transactions with all that information here. So that's pretty straightforward. And when these get created, some of these things will be encrypted, like the social security number, the account number, and stuff like that. Well, I guess that's the credit card number, the social security number. Okay, now we're going to run some commands to create the encrypted collections and populate them with data. So first we have PHP bin/console Doctrine MongoDB schema create. So this is going to create our collections that we've already defined based on the transactions, based on the accounts and the transaction documents. Okay, done creating. And now we can run that command we just created, which is to create the demo data. Okay, so we run PHP bin console app demo data. We create these demo accounts, we create these demo transactions. Okay, the demo data is created successfully. Okay, we're almost done, but next let's create our front-end code. For the user interface, we just have a simple HTML file with some JavaScript to interact with our API. So I'm just going to go into the public folder. We have index.html. Okay, I'll paste in the HTML here and let's take a look at it. Honestly, we're not going to spend a lot of time because we're just about to see it live in the browser. But basically, we have some CSS at the top, and then it's just going to have a list of some of the features, and then it's basically a few different forms. We have the create account form where people can type in the customer name, account number, and so on and so on. Create transactions, basically some forms where we can create transactions. Then here we're querying the data, so we can find account by number, find account by SSN, find account by balance range, and so on and so on. Find account by find transactions by account number. And so all of these are in our JavaScript below. So we have our script where we're making a request. This is our function, and this is how we're going to make the request and get the data back. But we really want, and also you'll see how the result just gets showed on the page in a little bit when we look at the demo. But here are all of our functions: get element by ID. And so here we are going to basically take the information in the form, make the request to accounts, making a post request to /accounts. We got the API base up here. It's all going to start with /API/harmony. And it's all pretty straightforward. For the get element by ID, we're going to for the create transaction form, we're going to the URL /transaction, and we're doing a post request. So anytime we're creating data, we're doing a post request. And now we have our query functions. Query by account number, so it's /account number. So we already created all these API endpoints, and now we're just using the API endpoints with the data from our web forms. So here's where we're finding the accounts by the balance range, and so on and so on. Again, you can see all this code in the description of this video. And one more thing before we test this out, if you're getting some errors, you may actually have to hard code your path in the Doctrine MongoDB.yaml to the crypt shared libpath directory with this MongoCrypt. Now, before I was using it as an environment variable, but now I'm just hard coding it in here. Depending on how you have everything set up, the environment variable method could work, or you may have to hard code it. So let's just start the application. So we'll do Symfony server start. And now we get the URL, and I can open up the URL. Okay, so this is what the application looks like. We have just a list of the features of our application, and then we have the sections where we can create an account, we can create transactions, and then we can query accounts, query transactions. So first, let's just find some accounts. We'll do get all accounts because we already added some sample data here. And so here we can see all of these accounts. So right now it's showing 4 accounts. Now I'm going to do the range selection, find accounts in these range here, and now we're only seeing 3 accounts. So now let's create a new account up here, and I'll just put in some information here, and then we will create my account. Okay, account successfully created. Now I'm going to search for the account just based on this account number. So we're able to find the account by the account number, and we can see the account number right here. We can also see the social security number. So now let's just go over to our MongoDB Atlas dashboard, and we're going to see what the data looks like right in the database. So if I go to Browse Collections here, and it's going to show a list of the accounts. And you can see the account number, the balance, the social security number, these are all just asterisks. The database, we can't actually see any of the information in the database, including the new one that I just added here, Bo Carnes, and you can see all the data is encrypted in the database. However, it becomes unencrypted once it comes back to our application. Because here we can see the account number, we can see the social security number, we can query based on the account number, even though the database actually has no access. You cannot see the account number in the database because it's encrypted. So even though the data is completely encrypted when it's stored and nobody can just access the database and see the data, we can still use the data in our application. And we can do the same thing with transactions. So I'm going to create a new transaction with this account number, and we'll just use all this as the default, and I'll do create transaction, and it's successfully created. And if we go into our database and we can see the transaction, we go to the bottom one, and this is the transaction that I just created. Now, if we go back over here, we are going to query the transactions based on the account number. And the transaction we created was for 1,500, so we'll find all the transactions within this amount range. This is an encrypted range query, so let me find the transactions within that range. And if we can see all this, so now we can see there's 3 transactions coming back, including the one that we just created. You can see this account number, that's the same account number as this, even though in our database, the account number is completely encrypted.
We've reached the end. We've successfully built a secure web application from scratch using Symfony, Doctrine ODM, and MongoDB's powerful Queryable encryption feature. This knowledge is helpful for any developer working with sensitive user data. You now have the principles and practices needed to build the next generation of secure, data-driven applications. Thanks for watching.